Safety Guardrails vs. Security Reality. A Claude user running Fable 5 asked it to check Windows registry keys for test residue. The model found something the user was not looking for, a hidden PowerShell persistence entry. Powers hell.exe no profile execution policy bypass window style hidden. Downloading a remote script on every sign-in, Fable correctly identified an active compromise, offered to remediate, and successfully remove the malicious registry keys. Then its own safety classifier flagged the session for cybersecurity work, forcibly downgraded it to Opus 4.8, and issued a strike. The AI had found real malware, eradicated it, and then punished itself for the job it just completed. The community response was immediate and brutal. Users reported getting flagged for routine security documentation, WordPress cleanup, and even botany discussions. The core grievance is not that Anthropic has guardrails. It is that the guardrails fire after the model has already safely completed a legitimate task. Penalizing retroactively accomplishes nothing except training users to avoid asking for help with the exact class of problems where capable AI assistance would provide the most value. When a $200/month tool can spot a persistence mechanism that your dedicated AV missed, the rational response is to improve the classifier, not to kneecap the model mid-session. The timing is ironic. Futurism and other outlets are running pieces on GLM 5.2, JPU's open weight model, warning that it can be downloaded by anybody, can be run on virtually any hardware, and that it raises cybersecurity stakes because there is no vendor playing the middleman. Security firms SemGrep and Graphistry did find the model competent at identifying software bugs. SemGrep titled its assessment, "We Have Mythos at Home." The r/local LLMA community promptly dismantled the framing. GLM 5.2 requires serious hardware, not virtually any, and as multiple commenters noted, if open models can find vulnerabilities, the solution is to use them to fix those vulnerabilities, not to ban the models. Meanwhile, the European Parliament cleared chat control for a second vote on Thursday, resurrecting a transitional regulation that had expired in April. The urgency motion passed 331. 304 pushed by the EPP at the behest of member states, despite Pirate MEP Marketa Gregorova calling it a violation of Parliament's own rules. Because this is a second reading, amendments or rejection require an absolute majority of 361. On the last session day before summer recess, when attendance historically drops, IT security researchers have warned about unacceptably high false positive rates from the AI scans used, and civil rights activists fear the renewed transitional status will relieve political pressure to develop a more targeted successor regulation. 4 EU commissioners wrote urgently that without the scans, abuse material would go undiscovered. Even though Meta, Google, and Microsoft are still voluntarily filing reports. The agent infrastructure gap. AI agents execute tens to hundreds of chained LLM calls per task, but every GPU scheduler on the market treats each call as independent, discarding gigabytes of KV cache between steps and inflating end-to-end latency by 3.8x. SAGA, a new distributed scheduler from the University of Hong Kong, argues this abstraction is fundamentally broken and proposes treating the entire agent workflow as the schedulable unit. The system introduces agent execution graphs that capture workflow structure, predicting KV cache reuse across tool call boundaries and achieving within 1.08x of Bellatti's theoretical optimal offline eviction policy. On a 6.4 GPU cluster serving S2 bench coding agents and WebArena browser tasks, SAGA reduced task completion time by 2.12.7x over vLLM v0.15.1 with prefix caching, while improving GPU memory utilization by 29 percentage points to 71%. The practical insight is brutal. vLLM v0.60 spends 38% of agent execution time regenerating KV cache that was discarded during tool calls. Even vLLM v0.15.1 with automatic prefix caching and affinity routing still loses 22% because it routes by shared prefixes rather than session identity. An agent session whose previous 32K tokens of conversation history were evicted during a 1.2-second code execution step must regenerate everything from scratch. On a 70B model with GQA, that is 1.07 GB of cache and seconds of wasted compute. SAGA's workflow-aware TTL sets retention time to the 95th percentile of each tool's expected duration, scaling down proportionally under memory pressure. The trade-off is real. Approximately 30% lower peak throughput than throughput-optimal batch scheduling. But for the latency-sensitive interactive deployments where agents actually run, that is a trade worth making. Below the inference layer, the tooling stack is filling in fast. OfficeCLI ships as a single binary. No Office installation, no dependencies, giving any AI agent full control over Word, Excel, and PowerPoint via CLI commands. A curl of a skill file teaches the agent how to install and use it. The built-in HTML rendering engine closes the render-look-fix loop that has been a persistent gap in document automation pipelines. Toolport tackles a different bottleneck. Every MCP server you connect loads its full tool schema into the conversation, and at about 6,500 tokens per session for unused servers,
That tax adds up fast. Toolport provides lazy tool discovery via embedding search, surfacing schemas only when relevant and flags rug pulls, tool poisoning, and agent jacking attempts. It supports 20-plus AI agents out of the box and stores secrets in the OS keychain. And on the frontier side, GPT-5.6 Sol Ultra has been confirmed for integration into OpenAI's Codex, the company's agentic coding platform. A signal that the model wars are now inseparable from the agent infrastructure wars.
Open models, brilliant demos, messy agents. Qwen 3.627b produces gorgeous demo HTML pages and generates impressively long single-prompt outputs. On agentic multi-turn work, it falls apart. One practitioner running the model at 8-bit and 16-bit on an RTX 6000 reports that every 4 turns or so it does something completely brain-dead, and after repeated attempts went back to 122B. The community response is instructive. The dominant theory is not that the weights are bad, but that the tooling around them is. On vLLM, the default XML tool call parser emits malformed JSON on multi-tool turns, poisoning downstream context. The chat template that ships with the weights handles reasoning blocks correctly only if left unmodified. Hand-rolling or regenerating it loses the boundary that prevents old reasoning from piling up in later context. Fix the parser, use the Frogoric-corrected template, set preserve thinking. True, and the model stabilizes significantly. The interpretability angle is sharpening. A developer tested Anthropic's newly published Jacobian lens technique on open models and turned it into a hallucination router. The idea: if the Jacobian matrix at a reasoning step shows competing activation patterns, multiple ideas alive in the layers, that correlates with uncertainty and often with hallucination. For llama models, the approach showed promise as a router, but Qwen's output confidence was already well calibrated, making the lens less useful. Community criticism was pointed. The labels in the published dataset contained factual errors, correct answers marked wrong. The logistic regression router was supervised despite label-free claims and normalization before cross-validation leaked information. The underlying signal may be real, but the story built around it outran the evidence. On the creative side, the local model ecosystem keeps closing capability gaps. A developer ported OpenMOSS TTS with full voice cloning, ThinkSound SFX generation, and Trellis.2 SOTA open source 3D generation to GGML for a 3.j S isometric RPG, shipping with CUDA, Vulkan, and ROCM support. Cascading model calls, text-to-image via stable diffusion into image to 3D via Trellis.2, are now available through the Lemonade SDK. Krea 2, the new open image model from Krea AI, ranks #1 among independent labs on Artificial Analysis's text-to-image leaderboard. It ships as 2 checkpoints: raw undistilled for LaRA training and turbo 8-step distilled for fast inference up to 2K resolution. Train on raw, run on turbo. LaRAs transfer cleanly between them. Prompt chain addresses the VRAM juggling act on consumer cards, chaining a small local prompter model with a larger coder and auto-unloading between them. Reasoning blocks now stream into collapsed panels, and multi-file output renders as tabbed views with zip download. And at the extreme end of efficiency, Ternlight packs a complete embedding model into 7 MB using ternary bitlinear weights and ships as a single NPM package. Embeddings in about 5 ms on CPU, entirely in-browser via WASM. No API calls, no server. Teaching reasoning models when to stop. The overthinking problem in reasoning models is well documented. Current LRMs perform redundant reflection and exploration even on simple or solved tasks, lengthening traces and introducing hallucinations without improving accuracy. Daikon from Harbin Institute of Technology and Huawei Noah's Arc Lab offers a training-free fix by showing that problem difficulty is not static but evolves dynamically during reasoning, and that this evolution is linearly encoded in the model's step-level embeddings. The method is elegant in its simplicity. Fit a ridge regressor on 600 training samples to map step embeddings to a normalized difficulty proxy remaining reasoning length, log transformed. During inference, the regressor estimates difficulty at each step boundary. When estimated difficulty is low, Daikon reduces the logits of reflection trigger tokens. Wait, let me reconsider, gently discouraging further exploration. When difficulty is high, those logits are preserved or boosted. Crucially, the method never forces termination. It adjusts probabilities, not hard stops. Across 4 model architectures from 4B to 32B and 12 benchmarks spanning math, QA, and coding, Daikon reduces token usage without sacrificing accuracy, and the regressor trained only on math problems generalizes to other domains. The finding that temporal difficulty evolution patterns transfer across reasoning domains suggests something fundamental about how LRMs structure their internal computation. The paper also confirms what previous routing-based approaches hinted at. Replacing adaptive difficulty awareness with a static suppression coefficient substantially degrades accuracy, because static suppression indiscriminately oversuppresses challenging instances. AI meets the real world. A Dartmouth undergraduate built Phosphor, a digital learning platform that embeds LLM-graded formative assessment directly into instructional reading material, and deployed it across 3 sections of introductory statistics with 151 students. The results are striking. Full dosage is associated with a 0.71 SD increase in final exam performance after adjusting for prior exam scores, and 1.30 SD unadjusted. Presented as entirely optional and ungraded, 90.2% of students engaged with it, against a baseline reading compliance of 1.015% for the same course. Claude Sonnet 4.6 grades constructed response questions against instructor-defined rubrics, and the study found a revealing natural experiment. When Module 2 switched to MCQ-only quizzes in response to student complaints about rigid autograding, the dosage-performance relationship vanished. R-squared dropped to 0.001. When constructed response questions returned in Module 3, the relationship came back. The implication is that the learning benefit comes from the act of constructing answers, not from exposure to content. Retrieval practice, not passive reading. On the fraud detection front, a team from Hong Kong Polytechnic University published the first multimodal dataset of Turkish phone scam calls, 100 aligned audio transcript pairs, and evaluated 7 LLMs Gemini 2.5 family, GPT-4o, Qwen variants across raw audio, uncorrected ASR transcripts, and human-corrected transcripts. Transcript-based inputs consistently outperformed raw audio F1 0.99 versus 0.97, and human correction barely mattered 0.008 F1 delta. The real finding is in the failure mode. Models refuse to process calls containing profanity, police impersonation, or extortion. Precisely the intimidation tactics that define real scams. Content filters triggered by vocal aggression counted as false negatives and drove the bulk of the audio performance gap. Safety systems designed to protect users from harmful content are systematically blind to the content that characterizes actual fraud. Anthropic, meanwhile, launched a usage reflection feature in beta for Claude users. The dashboard surfaces patterns, key topics, usage timing, task types, and invites users to examine the role Claude plays in their lives. It can set quiet hours or nudge breaks, and introduces a 4D skills framework: delegation, description, discernment, and diligence. The feature excludes incognito chats and health integration conversations. It was developed with MIT Media Lab and Boston Children's Hospital. In a related vein, one LinkedIn post arguing for AI readiness assessment suggests the strategic implementation knowledge, the how of AI deployment, cannot be written down or reduced to numbers yet, and that this is where all the margin lies. Anomaly detection and the 2% problem. CRAFTIIF is a fully unsupervised anomaly detection framework for multivariate time series that tackles all 4 structural anomaly types simultaneously: point anomalies, isolated spikes; distributional anomalies, sustained level shifts; temporal anomalies, rhythm changes; and collective anomalies, intersensor correlation breakdowns. The architecture uses 4 wavelet families: Morlet, Dog, Har, and Koiflet, each chosen for maximal discriminability of 1 anomaly type, feeding 5 structured isolation forests, 1 per type, plus a meta-IF for compound anomalies. An adaptive threshold based on Otsu bimodality detection and M8 estimation handles anomaly rates from 0.1% to 69.2% without any dataset-specific tuning. Evaluated on all 19 MTS bench datasets, it achieved mean VUSPR of 0.463, outperforming all 24 previously evaluated methods, including the prior best PCA at 0.329. The ablation results tell the real story. Adaptive threshold calibration alone accounts for 38% F1 improvement, the single largest component contribution. The 4-branch structured architecture adds 20%, the meta-IF adds 23%. Most revealingly, 6 of 19 benchmark datasets are shown to be fundamentally undetectable by any unsupervised signal statistics method. Genesis contains anomalous production cycles that are statistically more regular than normal ones, and GHL has constant value faults that score below the training distribution. This diagnostic framework, distinguishing method failures from dataset-level detectability limits, is itself a contribution that applies to any tree-based detector. The branch firing mechanism provides direct anomaly type attribution. When the dog branch fires, the anomaly is a spike. When Har fires, it is a level shift. No post-hoc explanation needed. A short essay titled 98% Isn't Much frames the broader point. A website that works for 98% of the population is failing 150 million people. A feature widely supported in general browser stats may only cover 70% of your actual audience. The author checked nested CSS support for a client site, standard since 2023, safe to use, and found 30% of visiting browsers could not render it. The 98% statistic is a lazy shortcut. Robust engineering is about gracefully handling the edge cases.
PostHog's decision to open source its full product analytics stack under MIT. Product analytics, web analytics, session replays, feature flags, experiments, error tracking, surveys, data warehouse, AI observability. Gives teams the visibility they need to find their own 2% problems without vendor lock-in. The FOSS repository at PostHog FOSS is purged of all proprietary code. Microsoft also released Lens on Hugging Face, though details remain sparse at the time of writing.